Hi all, have a good day. I'm K. Surya, working as Assistant Professor in the Department of ECE at SNS College of Technology. In this video, let us see about duality. Two electrical networks are said to be dual networks if the mesh equations of one network is equal to the nodal equation of the other network, so as shown in the figure. So on the left side it is shown the mesh equations. There are 4 loops, so we will be writing 4 mesh equations and finding out the current. Whereas in the right side it is you can write the nodal equation. This is a dual form. A dual network is based on Kirchhoff's current law and Kirchhoff's voltage law. So consider the figure shown here where it consists of a voltage source in series with 3 impedances Z1, Z2 and Z3, and the current flowing through it is I. So now if you apply Kirchhoff's voltage law in the network, you will be getting V is equal to I into Z1 plus I into Z2 plus I into Z3. So when you combine it, you will be getting V is equal to I into Z1 plus Z2 plus Z3. The dual network is based on Kirchhoff's current law and voltage law. So now you consider this diagram, which is network B. Here you are having a current source in parallel with 3 admittances Y1, Y2 and Y3. So the current flowing through Y1 is I1, current flowing through Y2 is I2, current flowing through Y3 is I3, and the total current is I. So applying Kirchhoff's current law in the network, we will be getting I is equal to I1 plus I2 plus I3. I1 is nothing but V into I1, I2 is V into Y2, I3 is V into Y3. So when we take V as common, you will be getting I is equal to V into Y1 plus Y2 plus Y3. See here we find that the equations 1 and 2 are similar in the mathematical form. So there we got V is equal to I into Z1 plus Z2 plus Z3. Here I is equal to V into Y1 plus Y2 plus Y3. So equation 1 is a mesh form and equation 2 is in the nodal form. So here the left side variable of the equation I is voltage. 1 is voltage and the left side variable of the equation 2 is current. Similarly, the right side is the product of current and total impedance of the circuit, and the right side of the equation 2 is the product of voltage and admittance of the circuit. So, it is needless to say these two networks are dual networks. From the examples, it is also clear that dual networks may not be equivalent networks. The circuit equation of the two dual networks are similar in form, but the variables are interchanged. So this is consider an RLC circuit. So here you consider you are having a voltage source V of t which is connected in series with a resistance, an inductance and a capacitance which is mentioned as R, L and C. And the current flowing through the network is I of t. Now if you write the Kirchhoff's voltage law, V of t is equal to R into I of t plus L into di of t by dt plus 1 by C into integral I of t dt. Now you replace this with the equivalent dual values. So instead of voltage, you write it as current. So I of t, instead of resistor, you write it as G. So G into, again I of t, you are replacing it with voltage V of t. Next, in the second term, inductor is represented by capacitor. In the third term, capacitor is represented by inductor. And again, current is represented by voltage, and so the equation will be, the dual equation will be, after replacing all the terms in the third equation, you'll be getting the fourth equation, which is I of t is equal to g into v of t plus c into dv of t by dt plus 1 by c into integral v of t dt. So if you draw the diagram for this, you'll be getting like this. So here you are having the current equation I of t. So current means everything will be in parallel. So G in parallel with L in parallel with C. So if you write I1 of t, I2 of t and I3 of t, you will be getting I is equal to V into, how will you write it? I is equal to V by R. Since it's G, you will be writing it as I1 of t is equal to G into Vt. I2 of t is C into dV of t by dt, and I3 of t is 1 by L into integral of V of t dt. So total current I of t is I1 of t plus I2 of t plus I3 of t. So this is nothing but Kirchhoff's current law. So as per the definition of a dual network, network C and network D are dual to each other. So this network, series network, and this parallel network are dual to each other. So this is a table for represents the dual elements. So electrical resistance, the dual element for electrical resistance is conductance. For inductance it is capacitance. For service branch it is parallel branch. For switch closed it is switch open. For charge you will be representing it by flux linkage, that is C with L. Next one is for mesh, you will be representing it as node. So these are the equivalent dual elements. Thank you for watching this video.